Okay. Yeah, this is Plutarch workshop. We are just gonna see some examples, implement some function, and see how we can improve the function we implement. So let's start with some history. So Plutarch was mainly developed in the early days of Plutus TX when it was unusable because it generated way too big code and it was essentially unable to fit in the 16 kilobyte limit. So I think it was originally Platonic Labs and MLabs.
Yeah,
who developed
during some initial work for Ardana, I believe.
Mm-hmm. Yeah, and a guy named Last and some other people developed Plutarch, and we got a few Catalyst funds, and I was assigned to maintain it. So we did a lot of rewriting and some other stuff, and now we have the current Plutarch. So originally it was mainly designed to optimize for the size, script size, but we repurposed it to optimize for execution unit as well.
It was like in Plutus V1 when you didn't have reference scripts yet, right? So it actually mattered. It was the limiting factor back then.
Now it's the memory, so we optimize for memory. So these values are vastly out of date, so just keep that in mind. So yeah, so let's see some comparison. I'm not sure if this means a lot, but good numbers, looks good. It's very fast. Also, Plutus TX here is out of date, I think. So
there are versions at the top. It's not that much out of date.
Oh yeah, that's true. Yeah, and we also have Cape, and we have entries. This is mine. This is mine. This is mine. So you can really squeeze out the juice by just tweaking all the levers and. Yeah, the strategy I took was to see the most optimal solution and just recreate that in Plutarch and make some adjustment to make it faster than the
That's how you win.
Yeah, that's how you win.
That's fine.
I played the game, but yeah. So why don't we try to implement Fibonacci? So
can you see on everything on the screen?
Yes.
I mean the font size wise.
Depends on what.
Yeah, let me just copy the code because I don't want to type.
Yeah, that's not what I can say.
Yes.
There you go. Oh, thank you.
Good.
Yeah,
Okay.
right.
So this is simple prefix. No, not prefix. Let's ignore this for a second and use regular pif. This is the simplest Fibonacci number function that one can come up with. It uses regular prefix with a z combinator. It uses regular pif with prime, which means it's not going to get hoisted, I think.
It's strict.
Ah, yeah, it's strict. Yes.
So pif is your usual if, and pif prime is strict, so it will always evaluate true and false branches.
But you will always recurse then, no?
No. But it's the application, so I don't think that's true. Is it?
Why would you want to always evaluate then an else branch?
Because it's cheaper.
It's cheaper sometimes.
So for example, if you are doing
one
like
else two.
exactly.
Yeah.
If you were to return something cheap like numbers, constants, or cheap computations, you don't want to delay integer and then force an integer, right?
Yeah, x here is just integer, so we don't have to do force and delay. So we use p prime, and this works. Maybe not the fastest, but it works. But if we let's see. Oh.
It doesn't work though. It's Plutarch level.
Ah, this one's
Touches.
yes. So we're adding the signature pound signs, and this still doesn't work.
Is this an apply?
Yes, the pound is applied. So if you have like a ID, which is A to A, you can lift this into the Plutarch by using plam, and this will do term S and then something like this. It's not correct, but you can lift.
Yes.
No, this has to be term.
Oh yeah.
Yeah, and this lifts a Haskell function into Plutarch function, and once it's lifted into Plutarch function, you cannot apply as a Haskell function. So we have a separate application symbol to apply to this.
It corresponds to apply in UPLC.
Yeah. So you can do this. So this is not entirely, because we do optimization for the application made using this. So if you want to bypass it, there's a p app.
Yeah,
This thing.
there's like the underlying primitive.
Yeah.
Yeah, because we used the SOP case.
Yes. Mhm.
Yeah, so if you apply, I believe, more than 3 arguments, it's actually cheaper to pack them in SOP const and distract it with case instead of applying multiple apply nodes.
Oh, you did.
You implemented that
Yeah.
because I posted about this on Twitter.
I saw it from somewhere else though.
It's a word of mouth.
Why doesn't this work? Do you have any idea?
It's a workshop.
It's a very good demo.
Yeah.
What's the signature of pfix?
Yeah. Perfect. The compile.
And
And
with block
print.
arguments, you can have a bit less dollars.
Yes. So this is the resulting UPLC, right? And this is clearly the prefix, and this part is the functional, which means this part.
Could you show it? Could you show it, please? I just want-
Bigger?
No, just want to see the.
Yeah. Yeah. So very simple. Nothing. No surprises here. But we can do better. We can actually inline the functional into the Z combinator. So let's do this. Normally, if you want to do something like that, you would have to make changes to the compiler, and that's a lot of work. But we can just do this. And
Or use template Haskell and your custom implementation.
no, you can't do that.
Yeah.
No. I think, yeah. So instead of making changes to the compiler or having a specific optimization path, we can just re-implement how prefix works. So the type signature for regular prefix was this, and you can see everything is in Plutarch level. But now, because we're inlining the fixed point, we can't do everything in Plutarch level, because we're inlining, which means we have to use the Haskell function. So if you inspect the type here, it's actually Haskell. So if you'd write fix in Haskell, it would be something like this. And it's essentially the same thing, except A is term as A to B. So if you use this, need to change
And yeah.
this. Yes, a lot of code, but yeah. This should be just R. Okay, let's just do this version. So what we do here, this is actually doing the inline twice. So it's putting F inside here and then inside here, which makes it a little bit more faster because, yeah. And the code is just what you expect. It just inlines the functional, which is the if statement, and the lambda that covers if statement. So this is the easy part. If you want to do more optimization, obviously you would need to change the algorithm, because you can this is if you're using the naive optimization with 2 recursion calls, I think this is theoretical limit as far as how fast it can go. So you can what you can do next is you can change the algorithm and make it a tail call, and that one's pretty boring, so I'm just gonna skip that.
And disclosure, what is all about, like the unsafe curves in here?
This part.
Uh-huh.
This is just here to make the Z combinator work,
Okay.
because this, if you write it out, it's something like this.
Yeah,
Mhm.
Uh,
doesn't have check.
and
Also in type on type.
yeah, and this breaks the type system, and
Yeah.
we can just say screw to the type system. And
Well, I mean, the Haskell variant also wouldn't type check,
Yeah,
right?
exactly.
Yes,
Yeah.
yes. The Y combinator type checks, but so the even better one is pre-packing all the things. Every Fibonacci sequence up until 25, which is the criteria. So what we're going to do is we're going to pre-pack all the value and then look up the value on the runtime.
And regarding type safety,
Mhm.
in practice, yeah,
Mm.
do you use unsafe curves a lot?
No.
No, not only for
Sometimes, yeah.
Well,
So
Rare,
for
but
example,
it's
like
similar.
we have P positive for a positive number, and this is a subtype of P integer,
Mm-hmm.
right? But sometimes, obviously, going from P positive to P integer, you can use P2, which is a safe way, and this is type safe, and everything's good. But sometimes you want to go to P integer to P positive without doing any check. In that case, you just have to do the fun thing.
Like usually when you interact also with ledger types, right?
Mm.
Like you know that phi is positive, but it is an integer because you get it from ledger.
Yeah.
Something salted.
TX
Yeah.
info. Yes. So yeah, something like this. Yeah, this is the new one, so everything is correctly typed. So prepacked. Yeah. So now we see the latest one, which is prepacked. We just prepare everything.
Plutarch virtual machine.
Yeah.
The only question I have, because we did the same,
Mhm.
but I actually wrote an algorithm that produces this constant rather than having it as a table.
Well, but mine's faster, no?
Well, yeah, but you don't
Often.
like
The off-chain part.
Yeah.
like the list. You don't have to include it verbatim.
Yeah.
You just write
Because it's
Haskell codes to
computed, yeah.
do it.
It's
No.
like 3 lines of code.
What?
I mean,
Oh, it's identical. Yeah.
Because it's
Yeah, we did the same
identical
thing.
code.
Yeah.
Like byte per byte, literally. You can check it out.
Okay. Yeah, that's fine. We did the same thing. We still used our variant of p-if, which prevents the hoisting. But here we use the p-force because we're gonna error when it goes beyond 25. So here you actually need the p-force and p-delay.
Then what's the point then to use custom if you anyway use delay and for it?
to not hoist it.
In what sense you can force it?
So because p-if you need to force it, right? The built-in must be forced.
Yeah.
So we pulled it outside to the top level, and we put on lambda, so we don't have to do it every time. But since we're using this once in the whole program, we can just
Yes.
do it.
I wanna
Yeah.
force
But-
it once instead
But
of
shouldn't
forcing
it get
every time.
inlined anyway?
No, I don't think so. The prefix itself is hosted, and everything that has
Okay.
so like if you have something you want to
Oh,
host, you
right,
put
right.
P,
Because you,
slick, and every function that has that is wrapped by this function will get hosted, and if is
but
wrapped-
wasn't there a special case if you use something only once?
no, we don't do that.
No?
Yeah,
Okay.
that doesn't always improve. So
Okay.
I just used inliner. I just passed it through and passed this as an argument, the string, and just inline it. Just inline it.
yeah. Yeah, but we use the new PIV. We check if it's bigger than 0, and we just pass it on a series of built-ins. So nothing too interesting in terms of Plutarch. Obviously, scholars can do it. Yeah.
I think there was one unique feature where you can do something with arguments, like passing only stuff that you need, not more, because of the metaprogramming.
You mean the data deconstruction?
Yes.
Right.
Oh, yeah.
Let's pull up the code for that.
That was like the coolest part of Plutarch.
I like that.
But nobody else does that. Maybe you can submit a scenario which only works for data deconstruction.
We do that with the construction. We can just give it type and say, just take these fields.
Yeah.
or that.
Let's see. Look at this beautiful SOP type level soup that I created. I'm very happy with this. So in order to do that, so what we need to do here is we need to, if you run pmatch, right, you're providing a Plutarch value. So this is some data, and this has type term as something data encoded. And we are also providing a handler. Let's put on the other line. D and D here is a Haskell value, Haskell data type. So at the Haskell level we have the deconstructor and the constructor for D here. So this is something like PTX info S.
We
And
have the same function with full differences.
yeah. And we can case on it obviously. So we can have different constructors and so on. And intuitively, this feels like every time we are running this function on UPLC, but it's not the case. And what it does actually is during the compile time, pmatch will inspect each branches of this function, and it will generate handler for each branches, and it will put it such that it will correctly handle the data given. So everything is handled on the compile time, and we are inspecting each branches.
I mean, what do you compile? You do unconster and then check the tag and then.
You can try like making it actually compile. Do you have Ledger API imported or no?
What is that? There's an example or
Let's try this.
Yeah.
Try this. Let's delete all the craps. So this one I can drive as data, and let's see. Pow and print pmatch.
To refresh the GHCI also.
Yes. Can't see the whole thing. Right. No.
So on conster, and then you check the tag, right? Yeah.
P bar and yes. So obviously there's the handler. It results in either 10, 1, and 2. So here it's 2, 1, and 10. So we can see it's generating handler for each cases. And so if we go back here, that's what we do precisely. This is actually yeah, and we're also hashing its handler. So sometimes 2 different branches have same hash. That means you can merge the branches, right? So on this example, we have 2 cases because we have 3 branches. But here, the last one takes 2. So we can merge the 2 cases and then put it on one statement. So this one only have.
In else, you do it in else, or you do it multiple ifs, or you create a lambda with the handler. How do you handle this?
We're using the if built-in because that's the only option.
So if tag 2 or if tag 3, then
Right.
Yeah.
We have a handler for that. So
it should be cheaper to introduce a variable, no?
No.
Why? You have multiple, so or would require multiple ifs, right?
I actually tested that and
So it may get cheaper when we will get case on integers, right?
Yeah.
Because
Sorry?
using a variable for handler may be cheaper when we get case on integers.
We have cancelled integers because of the tags. Tags are integers.
Yeah, but it compiles to if.
Yeah.
I meant the UPLC level case on integers.
In that case, yeah, but for now.
Yeah,
For now it's gonna be if,
yeah.
so...
yeah. So I have both implementation actually. So like
But sir, the variable for what?
For the handler.
no, we use
Why?
handler only once. That's the
If
thing.
we have case
Yeah.
on the
Oh, yeah,
case,
well,
then
well,
it would be
yes.
valuable, not probably useful.
It reduces the size, right? And we don't care about that.
Okay, you can talk a little bit. I'll write something more interesting. So keep the audience entertained, please.
I have a practical question. So Plutarch is on Hackage. I can just install it.
No.
It's not on Hackage, but you can use it without nix. Like you copy
I'm
paste.
using this, but okay.
You can also use it with nix. In the repo there is like a stanza that you can copy into your Cabal file, and
Why is it
About
not,
project.
Why it's
Yeah.
not on Nix? Oh, okay.
chat or hack?
yeah, well, it's not on Hackage because it depends on IOG's libraries,
We can
What about chat?
and it's not on chat because probably nobody bothered.
Oh,
Does chat accept third-party packages though?
Maybe if you make a pull request, we'll find out.
Okay.
Okay.
so when I install the package, I'm getting some standard libraries. There was this prefix prime. It's not part of standard
No.
library. Okay.
A standard library is fairly
It's
limited.
for newbies.
Well, there's just not much there because what would you really expect, right?
Prefix prime, for example.
Well, there is a wrapper for every built-in and some utility functions, and
Ah.
there is Plutus Ledger API library. So you have all types for script
Right.
context.
Mm-hmm.
Yeah.
Okay. Please.
I think it should have. That's how it should have evolved. So we should have started with a simple lambda calculus, then this DSL, and then maybe produce a compiler from Haskell.
Yeah. Well, what I'd like to see is somebody compiling to Plutarch. It seems like a good compilation target.
Yes.
Plutarch as a compilation target.
In order to what?
Well, yeah, why?
What's the benefit? What's the problem you're solving?
Well, let's say you want to compile Marlow, right?
Yeah. Okay.
Like, I'd much rather do it to Plutarch than to raw UPLC.
Like Marlow, what do you mean by compile? Compile contract or
Yeah,
implement the interpreter?
No. Like, instead of doing the interpreter, compile it to UPLC.
Yeah, we thought about that, but
Oh, come on.
didn't. Okay,
There were various projects trying to make a high-level Haskell DSL that compiles to UPLC, but nothing really succeeded, right? Like ages ago, there was the state machine abstraction.
Mhm. It's too early. Too early.
Okay, yes. Yes. So here I created a sum type. So this is the sum type with a lot of integer arguments, fields, or so normally if it's a sum type, we can just encode this as a list in data. That way you don't have to, when you deconstruct it, you don't have to do two built-ins. If you use constructor, you have to do onConst and then do the first and the second, and then now you get the list. But if you use list, you can just use list directly. The cool thing Plutarch does is when you p-match on a sum type, or if you're using constructor, it will do the same thing on the list part of the constructor. It will inspect the handler code and check which fields are being used.
Mm-hmm.
And if you don't use certain fields, we can just skip the entire thing and then jump directly to the fields that are being used. So
We do this in our code gem.
yeah. So you can see XF is the list we're giving, and we're adding first and second. So we don't have any lets. So we're just doing the getting the first one first and then do the second one first. Nothing too much interesting, right? But let's see.
But it really scales with the Ledger API type.
Because it's like 10 fields,
Mhm.
and you're not always using everything. So if you're doing the last one, you can see it's actually inline the constant. So this part is the array, and we're applying the tail list 3 times. And because we were taking the last 2 elements, we are tailing the first part, and then from the XF we're doing the first one and the second one. Let's see what happens if you do the first one and the last one. These, not the last one. It will do, yeah, normal thing. Well, be the interesting one. Yeah, let's do the first one, third one, and the last one. And now you can see here it's letting the middle one, which is
So like, my thinking was that, so I'm creating this library of expressions and see the execution budgets for each expression. So I want the backend to use this information to decide which optimizations to do. So if parameters change, it
nice,
will
yeah.
redo this automatically. So you did. I expect you to compute this, yeah, right?
this function.
So it lets the tail list, the double tail, right?
Yes.
So it is, because I did experiments, and I think for 2 tails it's still cheaper to just inline.
The original code.
Yes. I'll go over the code. Yeah. I think either yes. I think I put in the threshold manually, and it's either 2 or 3. If it's more than 2 or 3, I do the letting, and it will insert the let bind, which is just a lambda. But if we see the code, this part, the top part, what we do is first we have to note that everything is operating at the level of SOP. So we are changing the actual type, which is phello, into a SOP wrapper. So we are taking this and putting into something like p data rec that takes p integer 5 times. And we're using this to generate code generically. So here, this is a type, and we have the structure of the data. And we use...
representation, right?
Yes, representation, yes. And we use the type to generate a number prec of the handlers. So this will generate a record of same structure, so same number of arguments. Same number of arguments. Yeah. And this will generate such data. And we are going to apply the generated value into the given handler, which is the function part. This part of pmatch, right? So now, and you should also note that the placeholders are essentially errors, and instead of it being literally error, it will have a tag, integer tag. So, and each argument we generate will have different ID. So once we apply this generated placeholders to the handler, we're gonna have a term with the little terms that have unique IDs. So once we have that, we can generate through the AST and see which ID is actually being used and which are not being used. So we find the placeholders and we put them on a list and check which ones you used or not. And now we have that information, and we can actually go through the binds, and we can determine how much to skip and when to let and do something like that. So there you go. If this is last time, or we need more than 3 p-tails, you don't have to hoist. We need more than that, we can hoist the 3 and then use it later and do something like that. So in terms of complexity, this is very simple, and this isn't even a optimization pass. And frankly, I think this is easier to do when you actually generate the code instead of having a external optimization path, because to implement this as an optimization pass, you'd have to figure out how UPLC code looks like, how the UPLC code that tries to reach certain elements of the record looks like, and you have to match on that, which is more difficult. But this is done while generating the UPLC itself, and because you have to look ahead by injecting placeholders and counting it, it's easier.
This is a common sub-expression elimination optimization task, right?
Well,
done by the users.
Well, so
No.
what I mean is that once we construct the AST, it is basically directly translated into UPLC. Like we don't do anything else. It's just like it's optimal by construction.
Right, but the construction needs to be optimal, which makes it
Yeah.
harder to construct. Instead, you can have a simple thing to construct, and then the CSE pass that will fix it for you.
Sure.
So it makes it easier to construct, but the result is the same.
Yeah. Well, then you would also need a more complicated AST, because you probably want to preserve the information that this is pmatch in IST, right? We don't preserve it. You write pmatch, but you generate an
Clean
if.
has and does.
Yeah.
Right.
Do you know if the our optimizers can optimize it this far?
I know that it has a CSE pass
Yes,
on a PIR,
yes.
but I never tried it, so
Right.
I wouldn't dare to say yes,
Mm.
but maybe
Yes.
likely.
I think the CS and the other optimization passes can go pretty far, but I'm not sure which is better or.
Yeah. So, like my concern with Lambda optimizations is that they all make sense in like either theoretical or like as a separate domain. But with regards to UPLC and fee minimization, half of them don't make sense. Like common substitution elimination is not needed. It makes things worse in many cases.
Depends on what you're optimizing for, size
Yeah,
or
so,
a budget,
so
right?
if you just use like commonly known techniques to optimize lambda calculus, you'll make things worse in many cases.
So what happens
Surprisingly.
in practice when Adam does his validator and hits the limitation of the size, then I advise him to use the CSE flag certain way so that
Hmm.
it trades one for another.
Yeah.
So the default value for the flag is maybe not the thing that you want, but you can always tweak it and
Yeah.
see.
Well, I'd say that by default you should optimize for memory
Yeah.
in your
Right,
PLC.
so maybe the default is already that.
Yeah.
Yeah. So I would. I like
Depends on
it.
the use case.
Yeah,
I
of
would
course,
optimize
but it's
for fee. I would just make a function that calculates fee and just optimize for fee because it's a balance of size, memory, and
yeah,
CPU.
it really depends on what you're doing.
Yeah,
right,
if you
because
plan to max out the transaction.
If you're doing something so complex that you're hitting the
Yeah.
execution units limit,
Yeah.
right? You don't care about size or the fee anymore, right? You just need to decrease the units.
Mhm.
But if you're writing like something that will get executed a million times, yeah, you optimize for fee.
But I think it's a good default. Right?
Yeah.
Yes. I think Punt Optimizer can do the skipping part, but as far as I know, it will not hoist p-tails. We don't have optimization for grouping p-tails into three, so that part is missing. Everything
Yeah,
else
I think
can
so.
be optimized.
But
So
that's a nice
so
optimization.
obscure.
no, we're gonna have drop n, which will make everything.
Yeah, so no point.
Yeah.
at this moment.
So besides that, I think Punt have every optimization up until this point,
Well, I think,
which is good.
but it's not obvious if drop n will make things simpler, right? It depends on the cost.
No, cost is like
I tried it, does.
yes, it
Yeah?
does. Yeah.
It is
In the
true.
case on like the first, you did the first UPLC cape results and Linux just destroyed
Yeah.
everything. Just so slow. And how does it work? Just open the UPLC file and well, it's in the UPLC. We cannot do this. How does it work?
There was a psyop
It's new planes. We cannot do this.
They won't only use the casing, and
Yeah.
the only casing we did was replacing if then else. So casing is that much faster,
Yeah.
just for replacing if then else.
I still find it crazy. I mean, how?
This is essentially how this works. Obviously, we don't have to go through this complicated setup for SOP and Scott encoding because you have access to all the fields at once, and the case statements inject all the variables into the lambda you're providing as a case. So you don't have to. In fact, you don't have to do any of this. It just works efficiently. So.
I mean, so if we have a large structure as a SOP, right? Like 20 fields.
Yeah.
Then in order to process it, we need to pass a lambda with
Yeah,
20 lambdas.
Yeah.
And we use like first and the last thing.
Yeah.
And again, we have to construct this 20
Yeah,
lambdas,
but you
right?
can't avoid it.
How?
It's still efficient. It's fine.
Yeah.
The construction of lambda is constant cost.
Yeah.
And
but
then the
still we use like this one field. Why do I need to do?
That's the same as in Haskell, right? If you pass,
yeah. You have to do
Why-
like
why can I do like give me field number 5 and that's it?
It's the price of creation of thunk creation, essentially, right?
yeah,
I mean like from like I sometimes I think from like explaining imagine explaining our discussions from this workshop, from this conference, to EVM people, to Ethereum people. They are laughing at us. I'm serious. They're just laughing. It's
They're
just
discussing their.
this is laughable. Everything. I sometimes like, or Bitcoin. Tell this to Bitcoin people. You need to convert between byte strings and integers. It's costs something. It's very crazy. It's bytes in memory. Why do you need to convert something? Seriously, it's just it's inside to me.
It is what it is, you know.
Bitcoin scripts, I'm laughing at Bitcoin scripts.
Yeah.
Yeah, but I mean,
Reading it is crazy, yeah?
the thing is, what we are optimizing, we're fighting for the blocks space, and we're fighting for the fees, because we want it to be used by people, right? So that should be the optimization goal, right? And I don't hear this explicitly. So, you know, what we're doing this whole conference, basically, we're trying to invent hacks, or we're sharing our ideas of hacks, how to make this more usable, basically, right? Which is not the point. To me.
Well, yeah, I feel like we shouldn't have a discussion how to compile an if statement, but
Yeah, we should not be excited about having a good if statement, right? Again. Impressive work.
That's I think that's pretty much it. Unless you have anything else.
I think
If you have a question,
really
yeah.
was showing you something more as an arguments of some functions that I vaguely recollect what was
Okay.
that. But it resembled the structural typing or extensible row types where you can.
Yeah, yes.
You know what I mean?
Yes. I think you mean p-match list, and you can give type level argument of how many elements of list you want to match. No?
That
Okay.
was different. It was a function, Haskell function, that receives these terms as arguments, and something was like you instead of passing a record that contains more fields that you need, you have experienced that you can you still pass that whole record, but what happens in practice is that you pay and use only those that are used, like automatically. Something like that. Maybe
What do you?
So years ago we had this pdata rec, right?
That's doing the same thing though.
Yeah.
Yeah. Yeah. Like originally, the one I showed you, the implemented generically, it used to be done in a type level first. So here, yeah. Here,
you had to list. You had to pass a type argument that was a list of symbols,
Yes.
and
Yeah, maybe that.
well, yeah, but now it happens automatically.
Yes.
You no longer need to do
and
it.
and the type level was horrible, and everyone hated it. So this is
Well, so first of all, it was error prone, right? Because if you put more fields in the type level list than you extracted, then you still extracted. And if you put not enough, you will get a horrible GHC error message. But if you put too many, you will just like waste your time. Now it's way better, and now you can just define records as records. Previously, like records were like a new type over a wrapper.
P data record. And
Yeah.
you have to It used to be something like this all the time, and you need
Yes.
special accessors, which was bad.
I have a question. So far, I haven't written much Plutarch, mostly examples, but yeah. These, like, even when I implemented simple things like Fibonacci or factorial, when you construct these lambdas by hand, it's really easy to mess up and to lose the structure. How does it scale with writing more and more complex programs?
I mean,
How does
It kind of doesn't.
well,
Yeah.
how does it work?
What do you want?
Maybe you have
Just like
something-
the implementation in Plutarch. So in UPLC benchmark we have actual validators implemented in Plinth, Plutarch, Icon, and Option.
Like as with anything, you just have to know what you're doing, and if you know that, you can implement that. So
as always.
yeah.
How do I click? Oh, NFT marketplace maybe this one.
That's one.
I'm trying to find a reasonably complex one. Yeah, so that's how actual Plutarch validator looks like, and like you can't convince me that it looks way worse than Plinth. I think
Plinth does look a lot better. I think
I pretty much disagree, but
No,
I've
it's
been
just-
writing this for a while, so
it's a plain Haskell, so yeah.
It's not that bad.
A little bit more noise, but
well, yeah, like sure, there is some noise because it's an EDSL,
yeah,
But-
it's not
yeah,
bad.
but at the
It's not bad.
But at the end of the day, you. Oh yeah, that's. Well, yeah, but I mean, this is literally, almost literally how you would write it in Plinth, right? It's like, okay, this, I can't use. This is a bit awkward.
You just press it down.
So like
Okay.
these two lines are a bit awkward, right? Because you want to match on multiple constructors deep, and you have to do it in 2 lines.
Yeah, it's not bad.
Minor.
So, well, minor inconvenience, but sure. Like these are just, this would just be LED bindings in Plinth. This as well. Calling functions is fine. You need to remember about hashes. P from data is a minor annoyance.
It's just more ugly when you define, when you look at the definition of the function. Ugly in a sense, complicated. It's hard to immediately understand the essence.
Mhm.
But when at the call side, it's easier.
Well, the implementation of very internals, so handling, struct encoding, like that's complex, sure.
But so,
Yeah,
do I understand
exactly.
correctly, you have implemented some sort of a standard library to work with values and
Yeah.
stuff like that? Okay.
But
Didn't you do that?
And this phantom typing, typing in
Don't
general
do this
gives me
like,
nice errors.
manually. If
Can I
have a
quickly
compiler
or
that does it.
You got used to it if you use it.
Okay.
Yeah.
yeah, but so if you have just a regular,
Haskell. Yeah.
I don't know, can you get VHC?
Type definitions or and
Let's see error message here. Yeah.
Yeah, but like if you
so
try
like-
to add, I don't know, an integer to a byte string. Yeah, and
Why everything with we cannot use the collision with the keywords. Okay. YP everywhere.
yeah, right. Like,
This is nice.
Yeah.
that's the normal Haskell error message, right? Exactly what. It's a better than one you get in Haskell.
Oh, yeah. My keyboard is. Oh yeah.
Actually, yeah.
Yeah, like ours is better.
One thing I want to flex is the interface to the constant
Oh, yeah.
value and lift the Plutarch value out of Plutarch is very nice.
Yeah,
So
it's
for example,
But the above Haskell error is strictly about from GHCI.
yeah, I think my GHCI I turned off the auto or something, but like so like plif pretty term and cost. So this is just putting Haskell integer into Plutarch, right? Let's say if you want to put Haskell integer list into Plutarch, you can do this by p built-in list, and then just pass in something like this, and it just works.
So you
But-
have a lifting sort of thing, right?
Yes,
Yeah.
yes. But
And
what's amazing is you can actually do different lists. So
yeah.
we have a Scotting SOP encoded list,
Mhm.
right? So which is P list. Oh, maybe not. What was the other one? Let's do maybe. I know.
Yeah.
Maybe data, and
The
then
constant should have any CPU memory cost.
It has 100 and 1600. It's startup cost plus one.
Okay,
one box.
okay.
And you can p-constant everything, including your own defined types.
Have lifting as well.
Yes.
okay. This sucks.
What, you don't have maybe?
Yes. List.
Oh, you can also show that you can p-constant as data. That's really cool.
Yes. So that's better.
Yeah.
You can do p built-in list, and then you can expect the integer to
built-in
be
list.
data. P as data.
Missing.
So
Yeah.
now, if you compare this to the original one, which is just integer, the sharp indicate that it's a data. So you can give same Haskell value for different representation, which is pretty nice.
It's really useful in practice.
But in Flint there is this lift type class.
Yes,
right?
yes.
That's-
Mhm.
I will do same with plug and say that most of these things we can do in Scala as well.
Good.
With few things that we will improve.
Mm.
Very similar. Cool.
Yeah, like I don't think we can have that much difference between Scala and Plutarch.
We
Yeah.
do basically, yeah. We
Oh,
have
oh.
terms we can construct. them.
Oh, and you can also go the other direction.
Yes,
So
and you can
go,
bring it back down.
yes.
Lowering.
Yes, you can also bring down the data one, and just works.
Do you plan to implement a two-party escrow benchmark? in Plutarch?
No, I'm not getting paid to maintain Plutarch, so
By the way, what's this story? So Plutarch, was it created in IUG or is it separate?
It was
project?
created at MLabs.
NL Labs.
Yeah, so Elos was working on a client project that was literally impossible to deliver using Plinth or Plutus TX at the time. Client had also a fair bit of money, so like the only solution was to invent our
Develop,
own
yeah.
in-house language.
I think the original plan was to manually write UPLC
Right.
Yeah.
by hand.
Yeah,
But
so
it got little-
there were a couple iterations. So we had like a simple assembler for UPLC that you just type it in a file, and
Basically, manual UPLC.
Mm,
yeah,
yes.
but with somewhat same syntax, it could do. I think it would rename variables for you, so you don't need to use the drawing indices. Well, yeah, it was the most bare-bone assembler.
And what about Purus? Did MLabs learn a lot from?
No, they didn't finish it, and it doesn't really work at
Yeah.
all.
So
Yeah.
the pilot work.
Yes.
It's abandoned.
Yes.
Yeah, so I remember talking to them, and one of the challenges was to get the representation of the pure script core, but with types, because by default it's without.
Yeah. Like, they spent way more than expected just fighting with a pure script code base rather than working on like actual UPLC specific things.
Which was like a high bar to reach. You could have done it without the types, or like taking the pure script core, untyped core,
Yeah,
and maybe compiling it to untyped UPLC.
maybe.
But if you intend to do optimization,
Yeah,
then
exactly.
types help. But
Mhm.
Yeah. I'm ashamed. It's a shame that nothing of that got upstream, but I also don't know if pure script guys would like to have typed IR.
I don't know.
I
So-
don't know. To be honest.
But now there is a fork of PureScript that has typed core. So that's nice.
But as far as I know, MLabs was not planning to contribute back
No,
to
no.
PureScript, yeah?
So somebody else did this core for PureScript with types?
No, MLabs did it.
Yeah, but it was interesting because they had to deal with structural typing, yeah? So
Yeah.
for sure they did like optimization or final pass and some kind of, which PureScript doesn't have, yeah?
Yes.
Which was really interesting for PureScript community, but they did not plan to contribute
Yeah.
back. You know.
It's a much bigger investment.
Yeah, it was quite annoying with row types, right? Because at some point you need to monomorphize them.
Yeah, so we have to do like global analysis of the whole code base, which is fine for
It's
smart
fine
contracts.
for them as well,
Yeah.
right? It usually produces single jobs.
Yeah, so PureScript compiles down to many languages, but if you look under the hood, it's stupid because, for example, they compile to C, but the structs are not structs. Yeah?
Really?
It's a map under the hood.
Oh.
They don't have this global path, yeah? So this is like a dictionary under the hood, even if it's compiled to C, yeah? Or to Go. Or to
Well,
We have
that's basically the same as in JavaScript.
Yeah.
Exactly, exactly. In JavaScript that's default, but
Yeah.
in the other languages you could have a struct, but then you have to do analysis and monomorphize the functions of
Right.
some kind of analysis.
Yeah, so they spend most of the time, writing a collector and monomorphizer and
Exactly.
rewriting core.
But PureScript community would be interested in that.
Well,
All 5 people.
I was one of them. Euro was one of them.
oh, so both members are interested.
So, is it maintained by Regina?
What?
The Plutarch.
By Catalyst Fund, I think.
No, they didn't get any help with funding.
Well, so it's not my
It was a treasury withdrawal, I think.
there's
like-
funding.
But
I
like
thought you were doing Plutarch.
I used to do
he's
Plutarch.
doing graduate school, so yeah,
I'm at school now.
more fun stuff. But like honestly, there's nothing else to add. To be honest.
That's also true.
Yeah,
Like I think
What you're
Plutarch.
saying about new changes and old stuff.
but like built-in casing, even built-in casing, it's like one line change,
Yeah.
and because you can manipulate. We saw.
Too hard package, yes.
Well, generally, software does have this problem with saying that, all right, we're done. This is the product, and I think Plutarch is in a really good place,
Yeah,
right?
Yeah, like
It has been production ready for years. It supports Plutus v3. It supports all new Ledger API types. It's ready. Just go use it,
And
right?
people
Yeah.
use it. People use
Yeah,
it. Right?
yeah.
do
Absolutely.
they?
I agree.
Yeah.
Generally.
Mean swap is recognized.
Oh really?
But
Oh, wow.
people sometimes have
Genius
this, people
Yeah.
sometimes have this impression if there are no commits, the project is dead.
Yeah, yeah.
This
what
is
I-
crazy.
I
Yeah.
got this impression.
There is a
But
development
this
branch.
is bad sometimes, yeah.
Yeah.
If,
Yeah,
if
you're
it's a language, you don't want to change it frequently.
Yeah.
Mm.
Maybe update a banner.
The most important is version 1 point something.
Mhm.
It's very unusual for Haskell, and it's maturity scores, right? So to me, it's like super
Feature complete.
Feature complete, yeah.
GHC10.
10, it's
Yeah, yeah.
insane. It's just cool. It's super duper.
Wait, is GHC10
I
a
saw
thing?
11.1 version.
Yeah.
Even better.
But yeah. Essentially, this is Plutarch. Not sure if there's anything more.
Cool.
Yeah.
Thank you.